Lissajous patterns or Lissajous figures, which are sometimes called Bowditch curves, because they were originally investigated by Nathaniel Bowditch in 1815 and then later developed in more detail by Jules Antoine Lissajous in 1857, are something that some professors absolutely love. Maybe you're lucky enough to have one of those professors. Lissajous patterns can sometimes be fun to create and observe, as you'll see in this lesson, but they actually do have practical applications. So, what is a Lissajous pattern? As I think you know, oscilloscopes are normally used to plot voltage versus time, but a Lissajous curve is a plot of channel 1 versus channel 2, and it can produce some really strange shapes. Hi, I'm Johnny Hancock, Product Manager for Keysight's Infinivision oscilloscopes. Let's start with the simplest Lissajous pattern, an ellipse or oval. So here are two 20 kilohertz sine waves. They've got pretty close to a 30-degree shift between channel 1 and channel 2. I'm using two channels of the function generator to produce these signals. Now, normally you'd be probing some system, two different signals, maybe in some type of RF mixer or something like that. Let's see what this looks like in the XY mode, which will create Lissajous graphs for you. So where you select that is in the horizontal section of the menu, go into the Acquire menu. It might just say Menu on yours, and up here it says Time Mode Normal. Normal simply means volts versus time, or if I was using a current probe, current versus time. But I can select the XY mode. The X is always channel 1, so channel 1 is plotted on the horizontal axis, and Y is always channel 2 is plotted on the vertical axis. And so this is what a 30-degree shift of two sine waves looks like in the XY mode, or this is what the Lissajous. So you get an ellipse, and there's actually, you can see a graphic on your screen now, a way to actually measure the phase shift based on where it crosses the zero here versus the peak. And I did this yesterday when I was rehearsing for this video, and it came out pretty darn close to 30 degrees. Now, let's assume we need to adjust something, tweak something, until they are aligned, 0 degrees phase shift. What I'm going to do is begin changing the phase on this generator. Now again, I might be using some sort of tool to adjust something, and then maybe go down and adjust in 1 degree increments until I get a perfect 45-degree line. That's a collapsed ellipse, so that's a Lissajous waveform as well. If we go back to the time domain, let's see what that looks like. And now you can see, it looks like there's only one sine wave there, but they're actually perfectly aligned. But I was able to do it in the X versus Y mode. Now, what would happen if, let me change my frequency by about, so this is 20 kilohertz, I'm going to change it by a half a hertz. So I'm triggering on channel 1. You see it locked right at center screen, and you can see channel 2 just kind of sliding through. It's no longer locked. We have a 20 kilohertz and a 20.0005 kilohertz signal. Let's go back into the XY mode and see what that looks like as a Lissajous waveform. There you can see it beginning to rotate. And if I increase the frequency, you'd see it rotate faster. Now, watch what happens if I increase by harmonics. You can get some very interesting looking signals here, and then assume that I wanted to tweak that. I could begin tweaking it until it's an exact harmonic, until it stops rotating. So basically, what Lissajous waveforms are used by most people is for tuning, tweaking things to get a certain alignment in terms of phase or frequency. The one area where I've seen it used, and it's not so much a Lissajous waveform, is there's a measurement on power supplies called Safe Operating Area, or SOA, where it's you're plotting voltage versus current in order to determine peak power. So as you can see, creating and viewing Lissajous figures can be kind of fun when you don't have anything better to do with your oscilloscope. But as I mentioned during the demonstration, the primary purpose of Lissajous figures is for comparing frequencies and phases of two signals, and then tuning those parameters for a particular pattern as opposed to tweaking parameters in an amplitude versus time format. You also sometimes see Lissajous traces on an oscilloscope as props in the background of movies and TV shows when directors want to make an environment look scientific and cool. The 1960s sci-fi TV program in the US called The Outer Limits, which, by the way, I remember, famously used an image of fluctuating Lissajous figures on an oscilloscope as the background in its opening credits. In my 42-year electrical engineering career working with oscilloscopes, I've never used Lissajous figures for anything practical, but I know that some engineers use them because I get asked about them all the time. If your professor is one of those that loves Lissajous figures, then perhaps you should ask him or her what they are used for. That's it for Lesson 15. Remember, to learn more about oscilloscopes, you can download various technical resources at the URL listed on your screen. In our next lesson, we'll be talking about different types of acquisition modes and display modes. See you in Lesson 16. Go Morgan State Bears!